All right, guys, this is the second video. Starting with number 14, we ended on 13, started with number 14. Oh, my bad. We ended on number 14, starting on 15. Find the product. That is ridiculously easy. Just distribute. 4x times 3x is 12x squared. 4x times 2 is 8x. 3 times 3x is 9x, and 3 times 2 is 6. These are like free points on the final. 8 plus 9 is 17. Of course, we're talking about x's. Bring down the 12x squared, the plus, and the plus 6. And we are done. Let's see which answer that is. Wait a minute. Sorry about that. The answer is this option D, I believe. Well, there's no letters, but there you go. Let's move on to question 16. Another one. Multiply r times r squared. R times negative 4r. Positive 4 times r, positive 4r. Positive 4 times negative 4, negative 16. All we have to do now is combine the middle terms, the negative 4r and the positive 4r. Those completely eliminate. There are no more r's, therefore leaving you this answer, r squared minus 16. Question 17, we obviously are dealing with the Pythagorean theorem, and they want us to find this missing side c. And the beauty is they're telling you that c is the hypotenuse. It's the side opposite of the 90-degree angle. So let's write down the Pythagorean theorem. It's a squared plus b squared equals the longest side, the hypotenuse squared. So it doesn't matter which one you call a or b. I want to call the shortest side 3. I want to call that the a. So that's 3 squared plus 4 squared equals c squared. And when we do the math, we're going to have 9 plus 16 equals c squared. And you know what? If I pause right here and I already think about, this is 3, this is 4, this is 5. That is a Pythagorean triple. I already know my answer is going to be 5. Okay, I already know the Pythagorean triple, the most common one is 3, 4, 5. They use that a lot, even in construction in the real world. They use 3, 4, 5 to determine perfect 90-degree angles. So we already know that the answer is 5, but let me continue demonstrating that the c will ultimately be 5. 9 plus 16 is 25. 25 equals c squared. And to get rid of that c squared, to get rid of the square on the c, we do the opposite, which is a square root. What you do to one side, do to the other side. You will have 5 equaling c. Now technically, it's supposed to be a plus or minus 5, but we know that there's no such thing as negative distance, right? We're trying to find the distance from here to here. That can't be a negative 5. There's no such thing as negative in distances when you measure it. So the answer is positive 5. Again, Pythagorean triple would have saved you all that time. Just remember 3, 4, 5. Okay, moving on. Question 18, another 90-degree angle. It says find the missing side. Once again, we are going to use Pythagorean theorem, a squared plus b squared equals c squared. And once again, the important part is to identify the c value. Where is the c value? It's the side opposite of your 90-degree angle, right? This is touching the 90 degree, this is touching the 90 degree. This one's the one that's opposite of the 90-degree angle. This is the longest side. That's the hypotenuse. That is the c value. So let's write our equation. A, obviously they tell you a, we don't know what a is, so that will be a squared plus b squared equals c squared. So the b squared value will be 6, and the c squared value will be 19. So we need to work on this. Let's first do 6 squared, that is 36. So I have so far a squared plus 36 equaling 19 squared. I don't know what that is. Hey Siri, what is 19 times 19?
19 times 19 is 361.
361, thank you Siri. 361, and might as well ask Siri, hey Siri, what is 361 take away 36?
361 minus 36 is 325.
325, she says. So we have a squared equals 325. And now for the final question, hey Siri, what is the square root of 325?
The square root of 325 is approximately 18.0278.
Approximately 18.0278. Okay, so when we look at these options, the 18.3 is the only one that satisfies that, right? 18.02, now the 7 rounds the 2 up to a 3, and that's how we get that answer right there, okay? Of course, it's a lot easier to use a calculator as opposed to Siri. Let's move on. Question 19. Question 19 is yet another Pythagorean theorem question. So let's get going here. We have a squared plus b squared equals c squared. So what is the hypotenuse? That is the number 25, okay? Because it's opposite of that 90-degree angle. So we have a squared. Now notice, I usually label the a squared the shortest side. They made the longer side. But of course, the hypotenuse is always the longest side opposite the 90-degree angle. It doesn't matter which one's a, which one's b. So let's just say a squared, we don't know the a, plus b squared plus 7 squared equals c squared, which is 25 squared. Okay. Notice that on this one I didn't put parentheses. It's really not necessary unless you actually have like square root values. Then it'd be a good idea to use parentheses. Anyway, let's continue solving here. We have a squared plus 49 equaling, hey Siri, what's 25 times 25?
25 times 25 is 625.
Thank you very much, Siri. Continuing on, we're going to subtract 49. Subtract 49. Might as well ask Siri just to be sure. Hey Siri, what's 625? Take away 49. And Siri is not responding. Okay, so that's going to be 576, I believe. Yes, it is. No, it's not. Yes, it is. No, it's not. Yes, it is. Let's rewrite it. A squared equals 576. We will square root the a squared, square root the 576. And I just paused it and did it with the calculator. That does give us the answer. A equals 24. Okay, I was freaking out right now because I couldn't find the answer 24, but they don't write it as the answer 24. I don't know why. They actually wrote it as you see right here, the square root of 576, which is our answer over here, the square root of 576. That's weird. Anyway, let's move on. Moving on to number 20. Solve. And it is a quadratic equation. Now, if I had a quadratic trinomial like 2m squared plus 3m minus 18, then I would worry about factor splitting and solving or using the quadratic formula. However, only because there's only one single m squared here, right? There's a single m squared. There is no other m's. It doesn't say 18m. So if I only have a single m and it's squared, let's isolate the m. Let's get it by itself on one side of the equal sign. So I am going to add 18. What I do to one side, do to the other side, add 18. My new equation is going to be 2m squared equals 18, which really means 2 times m squared. So I want to get rid of the multiplication of 2 by dividing by 2. What I do to one side, I do to the other. What do I have left? I have an m squared equaling 9. Now I want the m by itself. I do not want an m squared. So I want to get rid of the square by doing the inverse operation of the square, which is a square root and a square root. And we must remember that when we apply a square root in an equation, then you have to put a plus or minus in front of your answer. In this case, m equals plus or minus 3. That means positive 3 and also negative 3. So there's your answer. Okay. This is true whenever you apply a square root in an equation. However, when we do the Pythagorean theorem, when we're trying to find missing sides of triangles, remember that there's no such thing as negative distance. So that's why we would not include the negative as your answer, just the positive, if you're talking about Pythagorean theorem, trying to find missing sides of triangles. Anyway, let's move on to question 21. Question 21, we have a standard form quadratic trinomial that's set equal to 0. And you could use the quadratic formula. However, you could also factor, split, and solve, especially because the a value in front of the variable is 1, right? So when you don't have a number out there, you could try and factor it. Put an a right there, and think what times what is a C value, negative 21, that if you combine together is a B value, which is 4. You might need to make a list, right? How could you get negative 21? Negative 1 times 21, or negative 2 doesn't work, negative 3 times 7, negative 4 doesn't work, and so on and so on. Those are the only two possible ways of getting negative 21 as an answer when you're multiplying two numbers. Anyway, which pair of numbers combines together to give you the middle value, positive 4? Positive 21 take away 1 is 20. That didn't work. 7 take away 3, yeah, that's 4. And I don't have to change any signs. These are the pair of numbers that I want. So I'm going to put the negative 3 right here and the positive 7 over there. And I have factored it. But remember, factoring is just changing it from this to this. And it's still equal to 0. So I still need to put equals 0. All we did was do a reverse distributive property, right? And got this factored form situation. Now we need to think, well, if you have a binomial times a binomial and the answer is 0, then the first binomial, a minus 3, that could equal 0. And the second binomial, a plus 7, that could equal 0 because of zero product property, which means that you're going to end up with two answers. Add 3 to both sides, you're going to get a equals 3. That's one answer. Subtract 7, a equals negative 7. So there's two answers, positive 3 and negative 7. And that, of course, is right here, positive 3 and negative 7. Let's move on to question 22. Question 22 is slightly different because the a value is actually a 2. The a value is a 2. The b value is negative 3. C value is negative 35. So you cannot set up parentheses xx because there's a 2 right there, right? X times x is not 2x squared. So you might have a 2 here, you might have a 2 over here. So we cannot just jump right into the factored form format. So what I'm going to do is erase it since we can't use it. But I will use that multi-step method that I showed you. The first step is to multiply a times c. And of course 2 times negative 35, that is a negative 70. And of course you could use a calculator. Step 2 is to think of the multiples of this answer that combine together to give you the middle value b, which happens to be negative 3. So let's make a list. How could I get negative 70? Negative 1 times 70, negative 2 times 35, negative 4 times, that doesn't work. If you're not too good at this, get a calculator and do 70 divided by 4. You'll see that it'll give you a decimal. It doesn't work. So I'm going to try negative 5 times what? That's 14. Because with the calculator, 70 divided by 5 gives me 14. 6 doesn't work. Negative 7, that'll be negative 7 times 10. And those are all the possible ways of getting the multiplication answer of negative 70. All right, so which pair of numbers combines together to give us a middle value negative 3? That gives you 69. This gives you 33. This gives you 9. Negative 7 plus 10, that's a positive 3, and that's a negative 3. So we have the same number 3 in the number 3, but the sign's wrong, right? Negative 7 plus 10 is positive 3, and that is obviously a negative 3. So we have the right number, just the wrong signs, which means we have the right numbers, just the wrong signs. So make that a plus 7, make that a negative 10. A positive 7 and negative 10, that's the right pair of numbers that you want. Now step 3, using the shorter method that I showed you, is to plug in everything into your factored form answer format. And remember, what we're plugging in to the first part of each binomial is this part right here, the 2x, without the square. Okay, so we're going to put a 2x right here and a 2x right there. And then we're going to plug in the pair of numbers from step 2, the plus 7 and the minus 10, and we're just going to put them right in there. Now, this is incorrect, right? This is not the correct factored form, but it's a process to be able to get the factored form. So what's the fourth final magical step? Is to divide those binomials by anything possible. So right here, 2 and 7, there's nothing in common. You can't divide it, so we're going to leave it 2x plus 7. But the second binomial, the 2x and the minus 10, they could both be divided by 2. And if you divide 2x by 2, you'll get an x. Divide negative 10 by 2, you'll get a negative 5. And ladies and gentlemen, this is your factored form answer. However, they didn't ask us to factor, they asked us to solve. So we are factoring it to be able to split it and solve, all right? So let's actually split it. 2x plus 7, well, let me write the whole thing, times x minus 5. If that equals 0, that means that the 2x plus 7 could equal 0, and also the x minus 5 could equal 0. And if you solve both of those, minus 7, you'll have 2x equaling negative 7. Finally, divide by 2, and there's your answer. X equals negative 7 halves. And over here, plus 5, you get x equals 5. So our two answers are negative 7 halves and 5, which is over here. I know some of you guys are thinking, no way, man, this is even, you call this a shortcut? This is a long process. Okay. Any quadratic trinomial that you're trying to solve, if it's set equal to 0, you could always fall back on the quadratic formula, ladies and gentlemen. So if you don't like this method of factoring and then splitting and solving, well, first of all, sometimes you can't even factor it and you have to use a quadratic formula. So how about this? Let's go back and do this exact question, but with the quadratic formula. So here's a quadratic formula, and we are going to replace those variables with parentheses so we could plug in our a, b, and c values. So as we could see, the a value is 2. There's a 2 down here, also a 2 up here. The b value is negative 3, so we're going to put a negative 3 right there and a negative 3 right there. And the c value is negative 35, negative 35. That is ugly, but I hope you guys could see what I'm doing here. So let's work on the discriminant. I mean, first of all, the minus changes to plus. You have a 3 plus or minus the square root of, but let's find out what the discriminant is. All divided by 4 because 2 times 2 is 4. So the discriminant, let's work with the negative 3 squared, that's a positive 9. And then we're going to go 4 times 2 times negative 35. Let me do that with the calculator. I want to go negative 4 times 2 times negative 35. Gives me a final answer of positive 280. So I really have a plus 280 right here. And if I go the square root of 289 on a calculator, the square root of 289 on a calculator is 17, all right? So again, I had a 289 in here. And if you try to do the square root of 289 on a calculator, you will get 17. So you really have 3 plus or minus 17 divided by 4. Now the plus or minus is two situations. That means 3 plus 17 divided by 4 and also 3 minus 17 divided by 4. So 3 plus 17, that's 20. 20 divided by 4 is 5. That's one answer. And 3 minus 17, that's negative 14 divided by 4, which you can't really do. You can't divide 14 by 4, but you could definitely reduce by 2. So if you reduce, you get a negative 7 halves. So here are your two answers, 5 and negative 7 halves. I don't know if that was any shorter than the other method, but you now know both ways of solving this quadratic trinomial equation. Question 23, that one's ridiculously easy. Simplify the expression. All you got to do is remember the exponent rule 1, that when you're multiplying x to the third times x to the third, you really add those exponents. So the 7 in the front just stays, and x to the third times x to the third is x to the 6th. There you go. There's your answer for that one. Moving on to question 24. Simplify 6 to the negative 2. We must remember that anytime you have a negative exponent, you must grab it, move it to the other side, and the exponent will become positive. So since there is no other side, you put that fraction bar, and if you do move it down, it'll be 6 to the positive 2 on the bottom, and there's nothing left up on top, so you put in the 1 that's up there. Okay, so what is 1 over 6 squared? That's really 1 over 36, and that is your final answer for number 24. Question 25 is all about canceling, right? If you have 3 b's up on top and 8 b's on the bottom, you know that 3 of those b's, all 3 of them will cancel with 3 of the 8 and you'll have 5 left over. Same thing with the a's. There's 2 a's on the bottom, a times a on the bottom. Both of those a's will completely cancel with 2 of the 7, leaving you 5 left over up on top, which is why your answer is a to the 5th over b to the 5th. Okay, so, whoops, sorry about that. Let me move on to question 26. These are all about the different rules of exponents. So what happens when you have a power of 0? That becomes a 1. Anything to the power of 0 is 1. So imagine this is really a 1, so you could scratch that out, and what you really have is a to the 7th times 1, which is pointless to leave it as a times 1 because it's not going to change it, right? And we also have this z to the negative 2. It's a negative exponent. You must grab that term, move it down to the other side, and it will become positive. Okay, remember negative exponents, they move from the numerator to the denominator or from the denominator to the numerator, and they do become positive when you move them. So what's our final answer here? There's a to the 7th left over up on top and a z squared on the bottom, which is right there. Moving on to question 27. Let's cancel some things out if possible. Let's move some things around if possible. So we do have negative exponents. I want to get this p to the negative 2 and I want to move it down here and it'll become p to the positive 2. So if I moved it, I don't have to, I'm just going to put a line through it because I already moved it down and it became positive. I'm also going to move this m to the negative 6. I'm going to move it right up here in front of the m to the positive 5. I want to put an m and it does become m to the positive 6. So since I already moved it, I'm going to put a line through it because it's no longer at the bottom, it's now at the top. So just to rewrite, just to make it more easier for you to understand, I'm going to rewrite it. M to the 6th times m to the 5th divided by p to the 4th times p to the 2nd. And of course, rule 1 says that if you have the same base and you're multiplying, you could really add those exponents. M to the 11th over p to the 6th. And there's your answer. Let's find it. There it is, m to the 11th over p to the 6th. And ladies and gentlemen, we're going to stop this video right here at 27. We'll do another video picking up on number 28.